This video is going to take a look at reviewing scientific notation. So that will include putting numbers in scientific notation and converting them out of scientific notation, comparing and ordering numbers in scientific notation, and multiplying, dividing, adding, subtracting numbers in scientific notation. To get started, let's just take a look at the definition. A number is in scientific notation if it is expressed as the product of two numbers that contain one with a decimal between 1 and 10. That would be including 1 but excluding 10, so it could get very close to 10 but not include it, and then a power of 10. So they are used to express very large and very small numbers. The steps to writing a number in scientific notation are to first move the decimal point so the resulting number is again between 1 and 10, including 1 but excluding 10. Basically, you want a number that has one digit to the left of the decimal point. The second number is always a power of 10, and we find the power of 10 by counting the number of places that the decimal was moved. Now, with very small numbers, those will be negative exponents, and with very large numbers, they will be positive exponents. And then we rewrite the number as the product of those two numbers. So I think this is review for most of you, but let's just take a look at these examples. In the first example, the decimal point is understood to be at the end of the 93 million. So in order to move that to create a number between 1 and 10, we would put the decimal between the 9 and the 3. So it's going to be 9.3 times a power of 10, and that power of 10 is going to be however many places we move the decimal point, which is 3, 6, 7. The second number, again, has a decimal point at the end, and so in order to create a number between 1 and 10, it's going to be 5.3, and how many places did we move that? 5 places. The third example is a very small number, so to create a number between 1 and 10, it would be 3.67. We moved it 1, 2, 3 places to get there, so that's going to be 10 to the negative 3 power. And the last one, 9.35, and in order to get the 9.35, we had to move our decimal point 1, 2, 3, 4, 5 places. So that's times 10 to the negative 5. Why don't you take a look at the next page and try those examples on your own? Okay, so I have the answers here for you, and any questions there, we can address those tomorrow when you are in class. To compare and order numbers in scientific notation, the first thing we need to do is be sure that they are, in fact, in scientific notation. So if the two numbers that are already in scientific notation have different powers of 10, it's very simple. We just compare the powers of 10. So 7 times 10 to the 11th compared with 8 times 10 to the 12th. If you think about those numbers, they're actually very big numbers, and since 10 to the 12th is got a higher power of 10, that's going to be a larger number. Likewise, if we look at 10 to the negative 6 and 10 to the negative 7, which of those is a bigger number? Well, 10 to the negative 6 is bigger than 10 to the negative 7, so that's going to be a larger number. If the two numbers in scientific notation have the same power of 10, then we would just compare the numbers by those first factors. So in the first example, 6.2 is greater than 3.0, so we know that the 6.2 would be bigger, and 7.9 is larger than 3.5, so that also is going to be a bigger number. You can go ahead and complete questions 1 through 4 on your own and come back and check. Okay, you could check those 4 answers quick, and then we will talk about ordering numbers in scientific notation. So to order numbers in scientific notation, it's basically just comparing them over and over again. The one thing that is similar to ordering any other series of numbers is that you'll need to make sure they are all in a consistent format, i.e. scientific notation. So the first step is actually to write them in scientific notation. So that process is done for you here, and then we will go through that comparison step, and then the last step is actually to put them back in the format that they were originally given to you. So that would be our step 3. Operations with scientific notation. Now, as you've heard me say in the past, it's definitely easier in many cases and more straightforward to multiply and divide in math than it is to add and subtract, and that is also pretty consistent here. All we have to do essentially is multiply the first factors together, and then use our powers of exponents with like bases to simplify the second factors. And basically what this is saying, use number properties to reorder and regroup the factors. It's saying that we can use one of our algebraic properties, namely the commutative property of multiplication, to say I'm not going to do this multiplication problem in that order. I'm going to take this part first and do the other part second, and I'm going to get an answer that's totally fine. So if I multiply 4.7 by 2.9, I get 13.63. I use my powers of 10, and it becomes 10 to the 14th. Now, there is one final step here. That number is not in proper scientific notation. So in order to do that, I need to move my decimal one place to the left, making it 1.363. Since I made that number smaller by a power of 10, I have to make this exponent larger by 1, or to make my second factor larger by a power of 10. And then if I divide, I would go ahead and divide the 1.5 by the 7.5, giving me 0.2. And I use my rules of like bases, which is -8 minus 5. So I get 0.2 times 10 to the -8 minus 5, or -13. And again, in this case, I have to move my decimal one place to the right, which means I'm making it bigger by a power of 10. So that's going to be 2 times, I have to make this smaller by a power of 10, which is actually -14. Let's just make sure my decimal is visible. All right, why don't you guys go ahead and complete that page and come back and check. So there you have the remainder of the questions, and you can just check your work there. Notice that I have this intermediate step here. This is required for your communication piece, where you need to show a little bit of the work involved in how you get your final answer. So really, to go from this step directly to this step would be a loss of a communication point, because you're not correctly showing the process required to do that problem. Now, the one thing you need to be careful of, and this is really kind of a side note, you will not have to be aware of this when you are completing math problems, but as I've said in the past, math can sometimes be a series of half-truths, and this is one such example. Real-world accuracy tells us that our final answer should not be any more precise than our original information. So if I were taking measurements, for instance, and I measured everything to the 10th place, how can my answer be to the 1000th place? It's not realistic. So I would have to actually round that and have it be 2.1 times 10 to the -4. Although that seems to be a loss of accuracy, it's actually the correct way in science to do most of your problems, because the answer cannot be stated to a higher level of accuracy than the number of digits actually in the least accurate number. So if any one of these was to a whole number, we would then have to round to the nearest whole number. Just a little side note for you. Finally, let's take a look at addition and subtraction. Now again, it's not necessarily difficult, it's just a little bit more annoying. In order to add and subtract numbers in scientific notation, they have to have the same power of 10. So I usually go to the higher power of 10 just because it makes that conversion step at the end less likely. So in the first one, they have the same powers of 10, so you can just go ahead and add those coefficients, and then that's going to be times 10 to the 4th. So I'm not going to go through that one for you. But the second one, I have a 10 to the 12th and a 10 to the 10th. So I'm going to go ahead and put this number into power of 12. So in order to get a power of 12, I'm making this bigger by 2. So I need to make my coefficient smaller by 2, which makes it 0.072. And then I'm going to add these two together. So I would get 3.572 times 10 to the 12th. And again, you're going to need to show some work on these for that communication piece of credit. So why don't you try some of these and see how you do, and come back and check your work. Alrighty, so here are the answers to those 6 problems. Now again, look at my work. It explains my process. If you are lacking some of this work, I would highly doubt that you're going to get full credit on the communication piece for the problem. At the bare minimum, you need to be showing this process. I would say it might be in your best interest too to show this, because if you made a mistake in that conversion, you're going to lose a point anyway. So that's basically it. Scientific notation in a nutshell. And I hope everyone has a nice evening.